Hello everyone, welcome back to yet another video from our channel Interactive Education, running for the best education possible from the student to the student. And today we're going to look at three good questions from the chapter Circles, which I have listed here below, and we're going to try to solve those questions, right? They are very good questions, they require some critical thinking, so let's have a look. This first question, okay? The inner radius of a triangle is 4 centimeters and the segments into which the point of contact divides one side of the triangle are 6 centimeters and 8 centimeters. Find the other two sides of the triangle. So first of all, let us try to draw a figure of this question. So they are saying that there is a triangle. So suppose let me draw a triangle, and they are saying that the inner radius of the triangle is 4. So what is in radius? If you know the concept of in circle, you can very well figure out what in radius is. In circle is the circle which is formed inside a triangle, which is formed with the in center as the center of the circle. And the in center is the point of concurrence of all angular bisectors. So wherever the angular bisectors of the triangle meet, that point is called the incenter. It lies inside the circle, inside the triangle, and taking that point as center, you can draw a circle inside the triangle. So the circle drawn inside the triangle is called the incircle, and the radius of the circle is called the in radius. And this in radius constant is a constant distance between the incenter and the sides of the triangle. So suppose this is my incenter. This incenter is equidistant from the sides of the triangle. So this, and this. All these three are equal and they are nothing but the radius of the circle. So this is 90, this is 90, and this is 90. How can I say it's 90? Because this is nothing but a tangent to the circle, right? So this is a tangent to the circle. The radius will be perpendicular to the tangent. Similar for all the other two. So let's name this triangle. Suppose this is some A, B, C, and the point at which the circle touches the sides are D, E, F, and R is the in radius. So they've given this in radius as 4. So they've said that in radius R is equal to 4 centimeters. They've given in radius of the triangle as 4. The segments into which the point of contact divides one side of the triangle are 6 centimeters and 8 centimeters. So let us take any one side. Let me assume BC. So they're saying that this D point, which is the point of contact of this tangent with the circle, divides this BC into two segments of lengths 6 centimeters and 8 centimeters. That's what's given, right? Now, what's the question? We need to find the other two sides of the triangle. That is, we need to find AB length and AC length. We know BC length because that's 6 plus 8, which is 14, right? We need to find AB and AC. So how to do that? Now, basically, they've given us this R. But before we do that, let's have some quick observations. So given, first of all, write down the given data. Given BD equal to 6 centimeters, DC equal to 8 centimeters, right? Now, it is given that BD is equal to 6 centimeters, right? So can I say it implies that BF is equal to BD is equal to 6 centimeters? So can I say that this will also be 6 centimeters? Yes, because this B is an external point from which I am drawing two tangents BF and BD to this circle, and we know that tangents from an external point to a circle are equal. So BF equal to BD equal to 6. Next thing, similar here, CD equal to CE. Again, tangents from external point C to the circle, right? Equal in length. So CD equal to CE, which is equal to 8. So let me put 8 centimeters length here. And the reason for this will be tangents from external point are equal. Right? So that's the reason. Now, that's what's given, right? Now, can I also say that AF and AE will be equal. Again, tangents from external point A to the circle. So AF equal to AE. Now we are not aware of their lengths. So let us assume that there are some x centimeters, right? Let us assume that there are some x centimeters, right? So we have done all that we could with this given data. Now what to do, right? Now, let me make this thing clear that it is impossible to solve this question, or it is possible maybe, but it's going to be very difficult to solve this question without a concept that you may not know. You may know it, but you may not know it. So I'll tell you that concept. The concept is related to in circle and area of the triangle, right? In radius and area of the triangle. Now there's a formula that the in radius of a triangle, that is radius of this circle inside the triangle, the in radius of the triangle is equal to area of the triangle by the semi-perimeter of the triangle. Area of the triangle by the semi-perimeter of the triangle. Using this concept, we need to solve this question, right? So you know that semi-perimeter S is equal to perimeter by 2, right? Half the perimeter. That's your semi-perimeter. So in radius is equal to area of the triangle by the semi-perimeter of the triangle, right? So we know the in radius. Can we calculate the area? Yes, using Heron's formula, right? Can't we calculate the area using Heron's formula? Yes, we can. So we'll use Heron's formula to find area of triangle, and semi-perimeter you can find it will be in terms of x, and you'll get an equation in x. Using that equation in x, you can solve this question very easily, right? You find x value, you find x, and then you find AB and AC. Using this, we can find it, right? So let's do that. First of all, let us find the area of the triangle. Now, area of triangle by Heron's formula, right? We learned this in 9th standard. I hope you remember. Heron's formula is equal to root over S into S minus A into S minus B into S minus C, right? Where S is the semi-perimeter, A, B, C are the sides of the triangle. So using this formula, you can find the semi-perimeter. So better find the semi-perimeter first. Semi-perimeter S is going to be equal to 6 plus 8 plus x plus 6 plus x plus 8, right? This plus this plus this plus this plus this plus this by 2. So this will be, if you solve it, you will get 28 plus 2x by 2, right? Which is going to be, 14 plus x. So this is going to be the semi-perimeter of this triangle. Use this in this Heron's formula. So you get root over 14 plus x into 14 plus x. Let me assume that AB is A. So AB will be A, that will be x plus 6. So minus x minus 6, because minus of x plus 6 minus x minus 6 into 14 plus x minus 14, because 6 plus 8 is 14. BC is going to be B. So 6 plus 8 is 14 into 14 plus x minus 8. Again, x plus 8 is AC. So 14 plus x minus of x plus 8, which is x minus 8. So here your x and x get cancelled. Here your 14 and 14 get cancelled, and here also x and x get cancelled. So you will get root over, after simplification, you will get root over 14 plus x into 14 minus 6, which is 8. This will be simply x, and this will be 14 minus 8, which is 6, right? So now let us try to simplify this without multiplying, which will be easier. So I can write this as root over 14 plus x into 4 into 2. 4 into 2 is 8 into x into this can be written as 2 into 3. Right? So here, what can you do? 4 you can take as 2 square, right? So 2 out into. Again this 2 and 2. Again 2 can come out. Root over what is left. So this is gone. This is gone. So 3x. So 14 plus x into 3x. So this will be simply 4 root over 3x into 14 plus x. Leave it like this. Leave it like this. Okay. Now come back to our formula. You know the semi-perimeter in terms of x. You know the area in terms of x. You know the in radius. You'll get an equation in x. Let's solve it. So using this formula, let's come back to this formula. So let me divide this area. So let's come to this formula. Using this formula, in radius is going to be 4, which is given in the question, right? If you see, the question is given, in radius is 4. 4 is equal to What's the area of the triangle? 4 root 3x. 4 root over 3x into 14 plus x by 14 plus x. Right? Easy. Now take this here. 4 into 14 plus x is equal to 4 into root over 3x into root over 14 plus x. Can I write it like this? Why I'm writing it like this, you'll understand in a while. Okay, it'll be easier for our calculation. So here 4 and 4 get cancelled. Now you see 14 plus x and root 14 plus x. Now can I cancel this and this? Yes, because root 14 plus x into root 14 plus x is 14 plus x, right? So this will become root 14 plus x, because this into this will be this. So I've divided them. Again, now you get as an equation, it implies root over 14 plus x is equal to root over 3x. Now cancel the root on both sides by squaring on both sides. You get 14 plus x is equal to 3x. You get 14 is equal to 2x. Therefore, x becomes 7. That's it. You are done with your question. You got x equal to 7. Therefore, AB, which is the first missing side, is 6 plus 7, which is 13. And B and AC, which is the second missing side, is 6 plus 8, which is x plus 8, which is 14. So the sides are, sorry, this is not, oh, this is 7 plus 8, right? So 7 plus 8 will be 15. Okay, let me just rub this off. Okay, so your sides are going to be 7 plus 8, which is 15. So the sides of the triangle are 14, 15 and 13, right? So the missing are 13 and 15, right? So all that you need is this formula and the use of the tangents concept, that tangents from external point to a circle are equal, right? So I hope it's absolutely clear. It's a very, very good question. You may get it in your board examinations. So I hope you're tension free now, because it's a very good question and you've got the answer, right? So that's for the first question we have today. The next question now, let's move on to the second question I have in mind, and that is also an okay question. With the vertices of a triangle as center, triangle ABC, so basically there's a triangle ABC. Okay, not like this, maybe better. So vertices of triangle ABC as center, basically there is a triangle ABC which I have taken. And with the vertices of this triangle A, B and C as center, 3 circles are described. Basically they're drawn. So A, using A as center, we have drawn a circle. Right. Using B as center, we have drawn another circle. And using C as center, we have drawn another circle. Right. So this is what we have done. Now with the vertices of the triangle ABC, 3 circles are described, each touching the other 2 externally. So you can see they are touching each other externally, right? This touches the other 2, this touches the other 2, this touches the other 2. If the sides of the triangle are 9, 7 and 6, find the radii of the circles. Find the radii of the circles. Please keep in mind that we don't know they are congruent circles. That means we don't know that they have equal radii, right? So please don't consider that. Now it's given that the sides are given, right? We need to find the radii of each circle. So if we say that the radii of this circle is R, can I say the radii of this circle will also be R? So let us assume that this is some D, this is some E, and this is some F. These are the points at which they touch each other. So if this is R, then this also has to be R, right? Now, let us assume that AB is some 9 centimeters, BC is some 7 centimeters, and AC is some 6 centimeters, right? So, therefore, let BF be equal to BD equal to R centimeters, because obviously radii of the same circle, they have to be equal. They are radii of the same circle. These 2 radii of the same circle and these 2 radii of the same circle. So radii of the same circle have to be equal, right? That's R, that's R. So if this is R, what will be the length of AF? 9 minus R, right? Because AB is 9, right? Since AB is 9, if this is R, this has to be 9 minus R, because the sum is 9. Similarly, this also has to be 9 minus R, right? 9 minus R. So what will this ECB. EC will be, because you know AC length is 6. So 6 minus 9 minus R. So this will be 6 minus 9, which is minus 3 plus R. So minus 3 plus R, that is R minus 3. Right? So this is going to be R minus 3. So this will also be R minus 3. Right? This will also be R minus 3. So R plus R minus 3. This will be 2R minus 3. So 2R minus 3 is this. So in this way, you have got the radii in terms of one variable. Right? In terms of one variable. So let us imply something. AF equal to AE equal to 9 minus R centimeters. And CE equal to CD equal to R minus 3, because this plus this is 6. So 9 minus R plus R minus 3. R cancel, 9 minus 3, 6. They have to be 6, right? Because it's given in the question, AC is 6. So I hope you got this right. Now using this R, we need to find the radii of the circle, right? So use any one equation and find the value of R. So how will you find the value of R? Take any one side and formulate an equation. Now given BC is equal to 7 centimeters, right? Therefore, R plus R minus 3, this has to be 7, because you know that this BD plus DC is 7. So 2R minus 3 is equal to 7 centimeters. Now, if you take this 3 there, you get 2R is equal to 10. Therefore, R is equal to 5 centimeters. So radii of this circle is 5 centimeters. So let this be circle 1, let this be circle 2, and let this be circle 3. Now, you got the radii of circle 1. So, radii of circle 1 you got. Let's name this as equation 1. Therefore, 9 minus R, which is the radii of circle 2, if you notice here, right? So, 9 minus R will be equal to 9 minus 5, which is be equal to 4 centimeters. Equation 2. And the last radii R minus 3, which will be R minus 3 is equal to 5 minus 3, which is equal to 2 centimeters. So, therefore, what do we say? Radius of circle 1 is equal to 5 centimeters. Radius of circle 2 is equal to 4 centimeters, and radius of circle 3 is equal to 2 centimeters. These are the radii of these 3 circles, right? So I hope you are absolutely clear with this question, right? It's a good question. Again, you need to use a bit of thinking, right? Once you're done, one variable, easy question, that's it, right? Let's move to the last question I have in mind today, which is this question, right? This is basically an NCERT question as far as I remember. This, I think the labelings of the line segments and all are different. Rest is everything is same in your NCERT textbook. So it says that AB and CD are two parallel tangents to a circle with center O. So there's a circle with center O. And in this circle with center O, we have drawn two parallel tangents. So basically, this is one tangent, right? And this is one tangent. Right? These are parallel tangents, right? These are parallel tangents, and they have been named as A, B, and C, D. Now, they with points of contact P and Q respectively. So if this is some P and then given this is some Q. Next part is a tangent RS is drawn intersecting AB at R and CD at S. So again, we draw a tangent. Okay, we draw a tangent. Again, a tangent. Let me draw a straight line. Actually, it's difficult to draw with the stylus. So yes, okay. So this is some R and this is some S, right? And this RS is a tangent intersecting AB at R and CD at S and touching the circle at point M. So this is some point M. Prove that angle ROS is 90 degrees. So suppose I'm joining R to O and I'm joining R O to S, right? I need to prove that this angle is 90. So how will I prove it? It's a very, very important question. Although it's an NCERT question, it is an important question. That's why I've given it to you. Right, so we need to prove that angle ROS, this angle ROS is 90. So how do we do that? First of all, you need to do some construction. So first of all, note this construction, which is very, very important in this question. Right? We're going to be using the concept of congruency here. Okay. So this one principle of congruency, which we'll be using here. Construction is first of all join OP, OM and OQ. Let me join OP, OM and OQ. So first of all, join these. You know that this will be 90 because it's parallel to the tangent, perpendicular to tangent. This will be perpendicular to tangent, right? So 90, 90, again straight line. It's going to be a straight line. So this PQ is going to be a straight line joining these two, right? So that is going to be 90, 90, and I'm going to join OM also. This will also be 90, right? And so will this, because again radius perpendicular to tangent, right? So now let's look at two triangles. Now the proof. In triangle OQS and triangle OQS and triangle OMS. Right? What can you say here? OQ equal to OM, right? Because they are both radii. They are both radii of the same circle, so definitely they have to be equal. Then OS equal to OS, again common side. It's a common side, so this has to be equal. And the last thing is that angle, this one, angle OQS is equal to angle OMS equal to 90 degrees. As I've explained to you, radius perpendicular to tangent, so they're both going to be 90. Therefore, triangle OQS is congruent to triangle OMS. By what congruency? RHS congruence. By RHS congruence, that is right angle hypotenuse side. Right angle hypotenuse is equal and side is also one side equal. Therefore, they are both congruent. So by CPCT, I can say angle QOS is equal to angle MOS is equal to some x degrees. So let us assume that this angle is some x. So this angle will also be x. Equation 1. Right? Next thing. That's my first part. Second part of the question is take other two triangles. The other two triangles which we need to take are in triangle OPR and triangle OMR. OPR and OMR. We can say that OP equal to OM. Again, they are both radii of the same circle. So again, this has to be equal to this. Next, OR equal to OR. Again, it is a common side. So both have to be equal, right? And the last part of this congruence which we need to tell is angle OPR is equal to angle OMR equal to y, sorry not y, 90 degrees, right? Again, as I've told you, radius perpendicular to tangent, so they are both 90. Again, because of these three, I can say, therefore, triangle OPR is congruent to triangle OMR by RHS congruence again, right? Again, by RHS congruence, both are congruent, right? Therefore, by CPCT, congruent parts of congruent triangles, we can say that angle POR, this angle POR is equal to angle MOR equal to some y degrees. So angle P, again this is equation 2. So angle POR, this angle and this angle are both some y, right? Now see PQ, the third part of this proof. It implies that PQ, can you see PQ? It is passing through the center, right? So can I say PQ is a straight line? PQ is a straight line, right? Can we say it's a straight line? Yes, because PO and then OQ, PQ is a straight line. Therefore, it has to be forming a 180-degree angle. It has to form a 180-degree angle through the center. Therefore, angle POQ has to be 180 degrees. And what is POQ? POR plus ROM plus MOS plus SOQ. So angle POR plus angle ROM plus angle MOS plus angle SOQ. This is 180 degrees, right? So POR plus ROM, Y plus Y, 2Y plus MOS plus SOQ, again x plus x, 2x equal to 180 degrees. There, which implies x plus y equal to 90 degrees. This is my MasterCard. Why? Because x is SOM also, y is ROM also, which implies angle SOM. So from here, if I can say angle SOM plus angle, because SOM is x and y is ROM, angle ROM is equal to 90 degrees. And what is the sum of these two angles? This culminating angle? Angle ROS, which implies angle ROS. Let me write this in another color. Angle ROS. Angle ROS is equal to 90 degrees. This is my proof for this question. NCERT question, very, very important question. Right? So I hope this is absolutely clear to you. If there is any kind of doubt, please post it in the comment section below. And with this, I conclude my third question. So I again took up 3 very good questions from circles. Thank you very much for joining me today. Goodbye. If you have any kind of doubt, please post it in the comment section below. And any kind of question which you would like me to explain, please post it. I will explain it in another video. So thank you very much for joining me. Goodbye. Best of luck for your mathematics exam. And I hope I'm trying my best to teach mathematics. If you feel it's good, please send a like. Also, some good comments are always welcome. Some appreciable comments are always welcome. And even some criticism is always welcome, because I always want to improve myself. So thank you very much for joining me. Please give a thumbs up, like, subscribe. Goodbye. Stay healthy, stay smart, and do keep studying. Bye-bye.